Good morning. I am doing the second page of your review guide, and I did want to clear up a couple of little mistakes that I didn't realize I'd made until after I went through the review guide in class. That happens sometimes. I'm going to flip back to the other page. It might look a little bit different than it did during the first recording. But what I realized on number 8 is that I forgot to put in a -2 here, and that would end up giving us a negative number, and your answer for number 8 should be -1/4. Also, I noticed on this problem, number 32, that I did not reduce my fraction. I think I left it as 8x to the 6th over 216 y to the 9th. And 8 over 216 does reduce to 1 over 27, and I should have reduced my fraction there. I think that's what I did, and if I did, then I'm sorry, and I hope that you see the corrections now. Okay, let's go on and get to this side of the paper. All right, when we classify by degree, what you do, especially if you have only one letter in your polynomial, then you look at the highest degree that you have. X has a degree of 1, and when you have a degree of 1, we call that linear. Now, there was a chart that I gave you in class that day, and it spelled out all of these. This one has only an x in it, and so we can look at the highest power, which is 2. And when it's 2, when the highest power is 2, we call that a quadratic. This one has no letter at all, so the power of that variable would be 0. When you have a 0 as your degree, that is called a constant. Okay, on this one, there are only x's involved. The highest power is 4. And when you have highest power 4, you can either call it quartic or you can say 4th degree. They are both correct. Okay, here, again, the highest power is 2, and we only have x's, so our degree is 2. And that would mean we have a quadratic again. And here we only have an x, and it's high, and the power is 3, so our degree is 3, and that would be called a cubic. Okay, when we classify by the number of terms, you take a look at everything, you count the things that are between plus or minuses, and you only count one term here, so that is called a monomial. Here you have 1, 2, 3 terms, and we call that a trinomial. Here you have 1, 2 terms, and we call that a binomial. We have 1, 2, 3, 4, 5 terms. Anything over 4 terms, we just call it a polynomial. And I'm going to shorten that to poly so that I don't run out of room to write it. And here you have one term that is called a monomial. And here you have 2 terms, 1, 2, and that is called a binomial. You do need to know these. It's like vocabulary and math. Okay, here, when you name the degree, you have to make sure that you only have one letter. If you have 2 letters, you'll have to do something different. If you have one letter, you take the one with the highest power, and that degree, the highest power is 2. And so the degree of this polynomial is 2. Now on this one, you have x's and y's. So what you do to find the degree, you look at each monomial within the polynomial, And this degree, 1, 2, is 2. And the degree of this polynomial is 2 plus this 1 would be 3. So the highest of those two numbers is 3, so the degree is 3. What I'm meaning is what you do is you add this power, which is x to the first, that's y to the first. You add the 1 and the 1 and get 2. Here you add the 2 and the 1 and get 3. Okay, for the next one, the power of this first term, or the degree of this first term is 3. The degree of the second term is 2. So the degree would be 3. Here you have only x's, so take the degree of the highest one, and that would be 3. On this one, you have an x and a y on your first term, and that's a degree of 2. Here you have a degree of 5, so the degree is going to be 5. All right, on this one, you have an m and an n, and that gives you a degree of 7, and this has a degree of 6. So your degree will be 7. All right, now we're going to start off with some addition and subtraction, and then we'll move into multiplication. Okay, you have x to the fourth, y to the third, x to the fourth, y to the third. You have the same variables raised to the same power, so we have like terms. You have 9 of them plus 3 of them, meaning you have 12 of them. The powers stay the same, you're just adding. So you have 12 x to the fourth, y to the third. On this one, you have two sets of parentheses and there is a plus sign between. So we're going to combine our like terms. X squared plus 4x squared is 5x squared. Then negative 7 plus 6 gives us negative 1. And that's your answer. We will do that for all the addition ones. Start with your highest power. That makes it a little easier for you. If you have x squared, negative 4x squared gives you negative 3x squared. 2x plus 3x gives you 5x. 1, negative 1 that is, plus 2 gives you 1. And that's your answer. Okay, on this one, the highest power is still x squared, so I'll do 3x squared minus x squared, giving us, or it's really plus negative x squared, gives us 2x squared. Negative 4x plus 2x gives us negative 2x. And then positive 10 plus 16 gives us 26. That's your final answer. Okay, subtraction works a little differently because what I do with this subtraction sign is I distribute it and I make everything in here change sign. And you can leave it like this except that you want to make sure that this negative sign goes to everything. So what you really have is 7x squared minus 3x squared, giving you 4x squared. Now the minus sign applies to everything in the parentheses, so just be very careful if you're not going to rewrite it. Negative 5x minus 2x is negative 7x. 10 minus 5 is 5. And that's your final answer. I'm going to do the same thing with this one. I'm going to distribute the negative. And I'm going to start with the highest power. It looks like that's x to the fourth. When you do 0, there's no x to the fourth over here, so you do 0 minus negative x to the fourth, which would give us positive x to the fourth, because when you subtract a negative, you're really adding. Okay, then the next highest power would be 3x to the third. Again, we do 0 minus 3x to the third, giving us negative 3x to the third. Okay, now we need to look at our squares. We have negative 8x squared, has nothing that goes with it, so just bring it over, negative 8x squared. Then our next term would be this, negative 3x minus 2x. That gives us negative 5x. And then the last ones, we have 2 minus negative 7. Again, when you subtract a negative, you're really adding. So it's really 2 plus 7, giving us 9. Now in class you saw me change every sign. I didn't have as much room here to do that, but you're welcome to do it the way that I did just now. You have to be really careful with the negatives. Okay, let's do this last one with subtraction and then we'll move into multiplication. Okay, so the highest power is x squared, so you have x squared minus 6x squared, which gives us negative 5x squared. Then we have negative 5x minus negative 7x, and remember that changes to plus, so it's really negative 5 plus 7, giving us positive 2x. Then the last one, negative 3 minus 8. That gives us negative 11. And that's your final answer. Okay, so now we're moving into multiplication, and it's mainly distributive property. We have quite a few problems to do, so let's get to it. When you multiply the big numbers, or the coefficients, and you add your exponents, the little numbers. So we have 12t to the second plus 36t. On this one, you get 6x to the sixth plus 18x squared. Now, when you get going pretty quickly, when you get going really fast on these, you have to pay attention and make sure you don't make little mistakes. This is where I kind of fall into a trap myself. Okay, so let's do the distribution here. That would be 21x to the third minus 28x squared. Okay, this one, I'm going to distribute the 7a squared to everything. You get 28a to the sixth plus 35. Now this one's different because you have an a and a b. But you get 35a squared b. Just slap them together. And the last term would be plus 28a squared. Okay, let's see, I'm going to distribute this 2x squared everything, and I get negative 6x to the fourth minus 4x to the third plus 4x squared. Okay, distribute again. There's so many of these. I want them to be right, though. I want you to get it right. Okay, so 3x times negative 4x to the third is negative 12x to the fourth. Then we have 6x to the third. Then we have negative 9x squared. And then we have 3x. Okay, now I'm going to distribute this. This one, you're going to have double distributive. The one you have to really be careful about is this minus 4, this negative 4. The negative will distribute with the other part. Now, after you use distributive property here twice, you may have to combine like terms, so just be careful that You may not be done after the first step. So you have negative 3x minus 9 minus 4x plus 24. Remember, we get plus 24 because you have a negative times a negative. Now, just as I was suspecting, you're going to end up with terms that can be combined. So you end up with negative 7x, and then here you combine that. That gives you 15. Okay, let's do the next one. It's going to work very similarly. You get negative 5n to the third minus 20n squared. That does not look like a square. Minus 6n squared minus 6. Okay, we're going to put together the n squareds. That's the only thing that goes together. Everything else stays the same. So you have negative 5n to the third minus 20n squared. Nope, that's not right. Let's get the eraser out. That'd be minus 26n squared. Minus 6. Okay. Now, the rest of these you can either use FOIL or you can use double distributive. It does not matter to me. All right, let's take a look. You have x times x, which is x squared. You have x times negative 6, which is negative 6x. You have negative 2 times x, which is negative 2x. And you have negative 2 times negative 6, which is positive 12. Now, each time you do a binomial times a binomial, especially in Algebra 1, your middle two terms should always combine with each other, provided you use FOIL. Or if you did double distributive, you would end up with something that looked like this. Your first term and your last term do not combine with each other. So you just have x squared, and you're going to have a plus 12 eventually. But you need to combine your two middle terms, and that gives you negative 8x, and then bring down your plus 12. That's your final answer. Okay, we're going to do the same thing again. X times x, x squared. X times 7, 7x. 2 times x, 2x. And 2 times 7, 14. Combine your middle two terms, and you get x squared plus 9x plus 14. And that's because you combined these two. Now, the idea behind FOIL or double distributive is that you need everything in the first set of parentheses to multiply by everything in the second set of the parentheses. So you're going to have 4 different multiplications here because you have 4 terms. All right, so let's get on with it. X times x gives us x squared. We have x times 7, which is 7x. Sorry, my plus sign doesn't look like a plus sign. There we go. Negative 2 times x is negative 2x. And negative 2 times 7 is negative 14. Now this one looks very similar to the one above it, but one was minus in this case. So when you subtract, you'll get a different number in the middle. You'll still have x squared, but this time you'll have plus 5x, and you'll have minus 14. Almost said plus. All right, here we go. Let's do the next ones. We have x times x, which is x squared. We have x times negative 11, which is a negative 11x. You have 6 times x, which is 6x. and you have 6 times negative 11, which is negative 66. Again, these middle two terms will combine with each other. Sometimes they'll cancel. Um, let's see, so you have x squared minus 5x minus 66. Okay, now we're going to move into ones that don't start with x. I gave you a little bit tougher ones. 5x times 2x is 10x squared. Nothing that you're not used to though. 5x times negative 2 is negative 10x. 4 times 2x is 8x. And 4 times negative 2 is negative 8. Okay, again, your middle two terms will combine, and you're left with 10x squared minus 2x minus 8. Okay, let's do the next one. 6x times x, it is 6x squared. 6x times negative 5 is negative 30x. Negative 3 times x is negative 3x. And negative 3 times negative 5 is positive 15. Yes, be careful with positives and negatives in this. They sneak up on you. Alright, so you have negative 30 minus 3. It's going to give us negative 33. So we have 6x squared minus 33x plus 15. Okay, now 40 and 41 are a little bit longer because you can see that you have a binomial times a trinomial. So instead of 4 multiplications, you're going to have 6. So it takes a little bit longer, and my hope is I don't run out of room. Here we go. So we have 2x times 3x squared. Those of you who like to use double distributive or even triple distributive in this case, you are still welcome to do that. I'm only using FOIL, or in this case a modified FOIL, because of room. Okay, so we have 2x times 3x squared. That gives us 6x to the third. Then we have 2x times 3x, which is 6x squared. Then we have 2x times negative 2, giving us negative 4x. Okay, then we've got to do the 3 times everything. 3 times 3x squared will give us 9x squared. Then we have 3 times 3x, which is 9x. And we have 3 times negative 2, which is negative 6. Okay, now there's going to be a couple of things that combine here. You have a 6x squared and you have a 9x squared. And then you also have a negative 4x and a positive 9x. Your first and your last terms stayed the same in this problem. So I'm going to now combine everything and we'll be done with this. So we have 6x to the third. The 6x squared and 9x squared give us 15x squared. The negative 4x and positive 9x give us positive 5x. And then you just bring over the minus 6, and that's your final answer. Okay, I know I've kind of crammed things in. I want to mention 42 and 43 in just a moment. Let's do this. 3k times 2k squared would give us 6k to the third. I like my sixes, I guess. 3k times negative 5k is negative 15k. Let's see if that's right. And then 3k times negative 5 is negative 15. And then I'm going to do the 4 times everything. 4 times 2k squared is 8k squared. 4 times negative 5k is negative 20k. And 4 times negative 5 is negative 20. Now again, some things will combine and some things won't. Your negative 15k will combine with your negative 20k. And how interesting. Let me make sure I did this right. Ah, I didn't. That is a 15k squared, silly. You have messed up a couple of things. Let's go back and erase that. I apologize. This should not be 15k. This should be negative 15k. This should be negative 15k squared, and this should be 15k. If you have done this correctly as you were going along, then I apologize. You're probably freaking out why I put the wrong thing there. It happens, but I'm glad I have an eraser. All right, so what goes with negative 15k squared is 8k squared. And what goes with negative 15k is negative 20k. All right, let me make sure. Let's go through it again. 6k to the third, negative 15k squared, negative 15k. Good, I got it right. 8k squared, negative 20k, negative 20. Okay, I have corrected my mistakes. So we have 6k to the third, negative 15k minus, plus 8k would give us negative 7k squared. Then the next one, negative 15k minus 20k is negative 30k. And then you just bring over your negative 20. Okay, I apologize that this is all crammed in here, but this is how the problems work. Now, if you remember from class, what I did was I added in a couple of extra problems which kind of shifted all the numbers down. So these are your new 42 and 43. What I wanted to give you were problems that you might see that involved squaring a binomial. And what I wanted you to notice that is that when you square a binomial, really what you should do is expand your binomial like this. What this means is something times itself. So you do x plus 9 times x plus 9. And you follow FOIL again like we did above. You would end up with x squared plus 18x plus 81. The tendency for us is to try to be really short with this, and we end up, instead of doing FOIL, which is an acronym for 4 things, first, outside, inside, last, we're really tempted to just do FLA, which would just be your first and your last. But the little square, if you expand your binomial like this, if you expand it into 2 of them, then you're more or less likely to just do FLA, and you will go, oh, I have to do FOIL. You can't leave out the O and the I. Okay, and then I gave you another one that was similar to it, where you expanded 3x minus 1 squared to 3x minus 1 times 3x minus 1. And you end up with 9x squared minus 6x plus 1. Okay, let's go up and do 44 and 45. Okay, it says, what is the area of a rectangle with a length of 3x plus 2 and a width of 4x minus 3? For a rectangle, area is length times width. So what I've really asked you to do is multiply 3x plus 2, which is the length, times the width, which is 4x minus 3. This is FOIL, and we will multiply just like we did the other ones. Okay, so 3x times 4x is 12x squared. 3x times negative 3 is negative 9x. 2 times 4x is positive 8x. And 2 times negative 3 is negative 6. Now you can combine your middle two terms, and that leaves us with 12x squared. We'll run out of room again. Minus x. And you can put minus 1x if you'd like to. That is not wrong. And you bring over minus 6. That's your answer. Now, the problem with word problems is we're used to getting an answer that is a number. This is an answer that is an expression. So it's okay to have that, and that would be 12x squared minus x minus 6 square units. And it's square units because area is square. Okay, now this one. I like this type of problem because it combines a couple of things. It says, what's the area of the shaded region? And what you do is you're trying to find this kind of, what would we call that? Like a disc, but it has this hollow middle. So what you could do is take the area of the whole thing and subtract out the yellow part here. So if you knew the area of the whole thing, that would be beneficial. How you find the area again is you find area is length times width, and in this case we have x plus 6 on this side and x plus 6 on this side. So we're going to find that area first. We have x plus 6 times x plus 6. And what we're going to do is subtract out the area of this yellow part. Now that is, and to find the area of that, you do length times width. So x times x is x squared. So we will subtract out x squared. Now we'll hold off the minus x squared until the very end. So we are going to use FOIL. X times x is x squared. X times 6 is 6x. 6 times x is 6x. And 6 times 6 is 36. Bring down your minus x squared. Now you can do a couple of things at once. You're going to end up combining some things. You have x squared minus x squared. That means they cancel out. You could put 0x squared, but you don't need to. You're going to combine 6x and 6x, giving you 12x plus 36. That means your area is 12x plus 36 square units. Again, you find that you have an expression for your area instead of just a number like 45. And that makes this a little different. But what we're trying to do, what I'm trying to do is make sure that you can apply expressions to things and use FOIL or use subtraction or addition with it too. Okay, that concludes our review, and you will still have your test on Friday, so my hope is that you will study hard and practice hard, and I will see you tomorrow.